Assalamualaikum and hi, my name is Rahim bin Amin, number matric AN180059, and today I will present my bachelor degree project 2 entitled Hydrostatic Pressure Effect Simulation of Linear Low Density Polyethylene LLDPE for the application of geotube structure under code M039, and my supervisor is Dr. Muhammad Aimullah bin Abdullah. And this is my poster design, which we have abstract, introduction, literature, methodology, result and discussion, conclusion, acknowledgement, and references. So we go to the next part, which is the abstract part. This study is focusing more to modeling, simulating, and analyzing a geotube structure under hydrostatic pressure change. So we collaborating with MYF, which is my Flexi Tank Industri Sdn Bhd. So they provide the material, which is the LLDPE, low linear density polyethylene, and this project use the only engineering software, which is SolidWorks 2020. So we go to the introduction part, which is in this study we want to change the current material to the newest material to enhance the efficiency of the product, which is in this study. MYF currently use the woven polypropylene PP as the main material for the geotube structure, and they want to change from PP to linear low density polyethylene LLDPE. So the objective of this study is to design a geotube for simulation purpose, and the second objective of the study is to determine the maximum value of bond mixture stress, displacement and strain due to hydrostatic pressure change. These are some of literature review that used in this study, which is from Ashish 2015. He said that geotube was invented with the usage of geotextile as the main material of it due to their excellent drainage and separation capabilities. Geotextile tubes were originally used in civil construction in the United States and Europe in 1960s for road building. And from Danesh Paye 2016, LLDP extensive variety of application in the packaging and automotive sectors. For example, it is due to its good processability, excellent mechanical characteristic, simple recyclability, and low cost. And from Kim 2013, geotube components are continually exposed to a variety of static and dynamic stresses, including wave load as well as lateral and overload pressure from embankment load, wake, and overlaid surface load. From DAS 2010, performance of geotextile geotube can be tested for dewatering process by finite element method analysis, which is FEM. So lastly from Lee on 2018 state that at various wave height level, hydrostatic pressure force will apply to the geotube. So we go to the next part, which is the methodology part, and this figure show the methodology of this study. We're starting from the first step, which is the literature review part, where journal and research paper were reviewed to find out more about geotube structure. And next process, the proposed problem model, which is what the output that may come from the simulation process. Then after that, we obtain the hydrostatic pressure parameter from other journal, paper, and standards. Then after gaining the pressure value mentioned before, we go to the process of modeling the geotube structure on SolidWorks 2020. Then after the modeling process, we can start to simulate the geotube. Then we observe the changes on the geotube due to the pressure change. Then after we get the result, we must decide that the result is satisfied or not. And if the result is not satisfied, we will go to the simulation back. But if the result were satisfied, we will go to the result and discussion part, where we conclude all the result and we make a discussion. So we go to the next part, which is the result and discussion. So as we can see in the figure, it is a simulation process of hydrostatic pressure change to the geotube structure, and we get the maximum von Mises stress. The value of maximum von Mises stress is due to the hydrostatic pressure, which is we allow to do until 2.8 kilopascal, because that is the maximum allowable, because the arrow indicates the maximum von Mises stress has passed the yield strength of the geotube. So the value of maximum von Mises stress is 12.906 for 2.8 kilopascal hydrostatic pressure. So next we go to the maximum displacement. So for the maximum allowable 2.8 kilopascal, we get 665.758 millimeter. So it is displaced from 0 to 665.758 millimeter from its original place. That is from the maximum allowable. Then we go to the maximum strain, which is hydrostatic pressure for maximum allowable is 2.8 kilopascal. We get the value strain is 0.036. So for the conclusion, this study was met its goal when the geotube structure were designed and simulated under hydrostatic pressure change for material LLDPE. And as for the recommendation, it's better to run a physical hydrostatic pressure, increase the thickness of the material, and conduct more testing to get validate result. So for the acknowledgement, this research was made possible by funding from research grant code M039 provided by the UTHM, which is University Tun Hussein On. And I would also like to thank the Faculty of Engineering Technology, University Tun Hussein On, for providing facilities in terms of access to information regarding this study. And I would also like to thank to MYF for the collaboration with UTHM to working together for success this study. And this is some of my reference regarding of this study.